So the next topic in this lesson is about a simple pendulum. So simple pendulum is an example of your oscillatory motion. Whenever an object displaces to and fro motion, you call that as your oscillatory motion. So before, as I told you an example of simple pendulum, let us look how it will be. So simple pendulum consists of an inextensible thread. Okay, the thread will not show any spring action. So it's a normal thread, and it will also have a bob which has some mass. Okay, so you'll have a heavy mass which is suspended from a thread, and this is a point of suspension. Okay, this is a point of suspension, thread and your bob. So it will be attached in one end. The other end will be like your pendulum clocks. Okay, just like your pendulum clock. Now what will happen, you just try to oscillate it. Okay, so once you give some external force, this will go and to and fro motion. It will exhibit your to and fro motion. This is how it will go. And the center position is called as your mean position, and the extreme points, this point A and B, are called as your extreme points. So as it goes to the extreme points, the height of the pendulum increases comparing to your mean position. So this to and fro motion is called as one complete oscillation. Okay, imagine I'm going to start from this point. Okay, I'm going to start from this center point, going to A, then coming back to mean B, and then back to A. So this is called as one oscillation. Clear? Starting from mean A, B, mean. So it is called as one complete oscillation of your pendulum. The time taken by the pendulum to complete this oscillation is called as your time period. Okay, so if at all it's going to take 2 seconds to complete one oscillation, therefore what is the time period? 2 seconds. Suppose it is going to take 1 minute to complete one oscillation, therefore what is the time period here? 1 minute, that is 60 seconds. Now to complete 10 oscillation, it is taking 70 seconds, therefore what is the value of one oscillation? Listen, to complete 10 oscillations, it is taking 70 seconds. Therefore, what is the value of one oscillation? You have to divide 70 by 10. Therefore, one oscillation value is 7 seconds. So, the SI unit of your time period is always expressed in seconds, because what is the SI unit of time? Yeah, second. Therefore, the time period of your simple pendulum is also seconds. So based on this, we have an activity where they have given a simple pendulum which is suspended from this point, and it is attached to a rigid rod. Okay, it is attached to a rod. Now they are going to oscillate the pendulum, and they are going to calculate the time period for 20 oscillations. So the time period for how many oscillations I'm going to take? 20 oscillation. Therefore, in order to calculate the time period of 20 oscillation, I have to divide how many seconds it has taken divided by 20, as I told you the previous example. Now consider for totally it has taken 200 seconds. Therefore, the time period of 20 oscillations will be 200 divided by 20. 0 and 0 get cancelled. So if you divide this 20 by 2, your answer will be 10. Therefore, what is the time period for one oscillation? It is 10 seconds. So this is how you will calculate, and that is the activity which is given. So generally, whenever you study about an activity, you have to first write the aim. What is the aim of this activity? I want to calculate the time period of a simple pendulum. What do you mean by time period? How many minutes or how many seconds it is going to take for completing one oscillation? That is what we call as your time period. So the materials required. So what are the materials it required here? It requires a simple pendulum, a rigid support. Okay, it just requires a rigid support, and a stopwatch, because I need to calculate. Since I want to calculate in seconds, I'll be using your stopwatch. Now what you do, the procedure is you have to suspend a simple pendulum, and you try to oscillate it. Now one oscillation, what do you mean by one oscillation? Okay, this is your center position. It has to travel your mean position. So this is called as my first oscillation over. Now next one is my second oscillation. So from here it will come back. This is my second oscillation, and next again this one. This is your third oscillation. It will keep on rotating in the same manner, moving in the same manner. So I have to calculate for 20 oscillations, and till that my stopwatch will be running. So once my 20 oscillation is completed, I have to stop my stopwatch. Then you note down your time. So now the time is 200 seconds. So time period for one oscillation means you have to divide it by 20. Therefore 200 by 20, you will get your answer as 10 seconds. So in this manner, you can calculate the time period for any number of oscillations, okay, provided there is no disturbance around your surroundings. Next one is non-periodic motion. And in your previous activity, you can also repeat this again and again to get an accurate value. If you want to get an accurate value, you have to do this 3 times or 4 times, okay. Now come back to the non-periodic motion. So far, until the last type of motion, everything was periodic. Everything is going to happen with some certain interval of time. So if it is not going to follow with fixed interval of time, then it is called as your non-periodic motion, okay. It is not going to happen with a fixed, not going to repeat in a fixed interval of time, then it is called as your non-periodic motion. Imagine you're going to drive a car in a traffic jam or in a heavy crowded area. So you might find the car is not moving in a proper direction, okay. So all these are examples of your non-periodic motion. So some of the examples are given here: swinging of your arms or legs while walking, the motion of vehicles car moving on a busy road, motion of a rolling ball which gradually slows down. All these are examples of your non-periodic motion. Next one is multiple motion. I had told about multiple motion in your previous video. I have given an example on that. Yes, if you recollect, you will get it. That is nothing but your hands of your clock. So your hands of the clock will also go for a circulatory motion, and it also does what motion? Periodic motion. Yes. So if two motions going to combine, then it is called as your multiple motion, okay. The motion in which combination of two or more types of motion is going to take place is called as your multiple motion. Now you look at your example here: the motion of a bicycle, motion of a drill machine, the motion of a pulley used to draw water from the well. So imagine what and all they are going to happen. So if you take a bicycle, the wheels are rotating, okay, they are going around a circular path and it is coming again and again. Therefore it is rotatory as well as translatory. So a drill machine is used by the carpenter shows rotatory as well as translatory. Yes or no? They're rotating and always they are going in a straight path. So anything which has two or three motions combined together, then it is called as your multiple motion. The last type is your random motion. Random means they does not have any desired direction, okay. They fly, they do anything in a in whatever direction they want. So that is called as your random motion. The motion in which the object changes the direction frequently is called as random or zigzag motion or irregular. They does not follow any particular path. It won't be circular, it won't be straight line, so it won't be periodic. Then that kind of motion is called as your random motion. So random motion example: flying mosquito, the motion of a football. You might feel the football won't be in a normal position at all. It will keep on flying high, it will be rolling in the ground. So that is an example of your random motion. So the flying kite, all these are examples of random motion.